Hello, I am Fabien Malbet, working in Grenoble Observatory at the University Grenoble Alps. I am going to present you a serious game to build decarbonization scenario in the astronomy academic community. This work has been done by many scientists in France, and here the co-authors are the ones who have specifically worked on the astronomy version. The motivation for this work comes from the fact that a growing proportion of the scientific community realizes that as scientists, we need to not only alert the population, but we need to change also our professional practices in order to reduce our greenhouse gas emission. Monitoring our footprints is, of course, the first and mandatory step, but it is insufficient to lead changes in our professional behaviors. We present here a new way to engage our community using the means of serious games that have already been used for almost 40 years in the domain of climate change. This is a good way to change our behaviors by combining learning and entertainment. As players, participants can then take positions or roles that are not necessarily their own and relate with issues that do not concern them directly or for which they did not think they were concerned. With this in mind, several members of the Institute for Geoscience in the Environment, IGE in Grenoble, have developed a serious game called Ma Terre en 180 minutes. That means My Earth in 180 minutes. This game aims at raising awareness regarding the carbon footprint of the academic world and identifying ways of reductions through social interaction. In this slide, you can see the timeline of My Earth 180 and the game board that is used. Each session is composed of 4 phases. The first and the third phases last 90 minutes, which with all the participants together and are at the heart of My Earth 180. Originally, they were taking place a few days apart. Phase 1 intends to build a common background of the topic among participants and to offer them the opportunity to know each other, a key prerequisite before further discussion and negotiations. I will not detail this phase today. During phase 2, in the few days between the 2 sessions, participants are invited to compute their personal carbon footprint with an open access simulator. They have also to learn the 2 characters they will play during the role-playing phase. So the most important phase here is phase 3, the role-playing phase, where 5 out of the 6 participants play the role of 2 different characters resulting from a virtual research group. The last participant, the 6th one, takes on the role of team leader. So each participant receives 2 cards describing his and her fictive character and their respective activities and mission. The set of 10 characters per virtual teams that you can see here on the game board includes different profiles from senior to technical and administrative staff. The description includes also their links with the other team members and also describe their own carbon footprint. The surface area of the tokens that you can see here in small is proportional to the GHG emission of each one and labeled with a specific icon that symbolizes the corresponding activity, going to conference or other things. After 25 minutes of introduction, presentation of the board, characters and tokens, the role-playing phase takes place in 3 subphases with 20 minutes of pre-negotiation phase, a small interplay where there is publication of result of research funding application, and then a second phase of 20 minutes, but which is guided. The objective of the team during the negotiation phases, the first one, the pre-negotiation and the guiding negotiation, is to perform the research while reducing the carbon footprint of their virtual team to reach a given target of 50% reduction. And phase 4 is dedicated to debrief by the umpire. This game has been created at the beginning by the geophysical community, but very quickly has disseminated in French labs in other communities, with some other colleagues who wanted to adapt the game board to astrophysical research and planetary science. Therefore, we decided to create a new team called Astrophysics and Planets. This work on astronomy and planets started with Julien Montillot from Itinéraire at Besançon, but was stalled for a while, and with Julien, Milly, Sylvain Doutet, and with the help of Henri-Claude Natat, we decided to finish the game board based on the assessment of GHG emission from our lab, IPAG, in Grenoble, and from our community based on the article of Knoedel-Seder 2022. The first tests were made during the spring, during the laboratory science days, and there was 3 tables gathering about 15% plus 3 moderators, and the game was validated and used in a larger session at the end of June 2022. We have built for this game a virtual team of 10 persons with 3 main topics in order to best represent the diversity of our work that you can find in an astrophysical laboratory. First, space instrumentation, but also laboratory work for planetology and simulation, observation, and data analysis. In addition to emissions due to travel for conferences of observation, we have added also emission from telescope observing time, estimated from the carbon cost of a night with a very large telescope, unit telescope, which is about 10 tons of CO2 equivalent per night, based on the work of Knoedel-Seder 2022. Initial GHG emission assessment for the team is of 97 tons of CO2, which correspond to about 10 tons of CO2 per person. Among the 10 persons, there are 3 permanent positions, senior scientists, assistant professor, junior astronaut, 2 postdocs, 2 students, 2 engineers, and 1 administrative staff. Half the team are women and half men. Here are the cards describing the different members of the team. We can see the name of the characters, the position, the type of research conducted, and a short text explaining the individual story and the emission footprint. I'm sorry, this is still in French. The footprint, which is displayed here, is divided in different tokens, categories that represent different icons, and whose size is proportional to the footprint. Here you can see the astronomy and planets team, who is composed of 4 people. Clarisse, a senior scientist involved in space observation of comets and interplanetary dust, and she has a footprint of 10 tons of CO2 equivalent. She has a postdoc, Sophie, working on instrumentation and space experiments, and also a PhD student, Victoria, in her last year working on data analytics. Benjamin is a research engineer working on instrumentation. In the next slide, you discover Monica, who is a junior astronomer working in lab experiment for planetology, with Sarah, who is an engineer that works in lab, and Adrien, a new PhD student working with Monica. In the last slide, you can see Maxime, an assistant professor working on simulation of planet formation, who is working with Frank, a recent postdoc who observes a circumstellar disk. And Leo is an administrative staff who is dealing with all the paperwork. You can see in this slide an example of emission reduction trajectory that has been reached with one of the first 3 sessions of this game in spring. At the beginning of the game, the team had a GHG emission of 97 CO2, and at the end, they have succeeded to decrease their emission by 46%. So you see here the total, and here the decrease. You have the 3 phases, the phase 1 with free negotiation, the phase 2 with guided negotiation, and you can remark here that in the interplay, the team has won 1 grant who had added some activity that increase the greenhouse gas emission, by 5%. But you see that in the free negotiation, the decrease that was obtained is less than the one that was obtained with the guiding negotiation with a team leader who conducted the negotiation. You see also here on the left the different types of emission that have been sorted here: travels, computing, and purchase. However, one session is not representative of the global trend, and you see in this slide the trajectory of the first 3 sessions in this astronomy and planet session, and the one that I showed you just before is the orange one. The goal of minus 50% reduction of GHG emission was very difficult to obtain without touching the core business. The most effective suggestions that have been made is a systematic replacement of plane to train for travels with a distance less than 2,000 kilometers, switch from face-to-face meetings to video meetings for work, the use of archive data rather than new data, the extent of the lifetime equipment, and mutualization of long-distance travels. The cancellation of telescope nights were considered unrealistic as an individual initiative by 2 of the 3 teams. The feedback of this session in front of the entire labs was very interesting to stimulate debate on the carbon footprint and GHG emission reduction commitment of our community. It shows that My Earth in 180 Minutes game is a good tool to initiate discussion on this difficult topic. At a larger scale, using a massive session that was held with 85 games, and you see here the different type of lab, and there was no the astronomy session for this type of thing, and you see that in the travels for conference appear to be the more powerful leverage in these research simulations. And you see that it's replaced mostly by video communication, but other alternatives. And if you look at the game with the time, so first free negotiation and guiding negotiations, you see that very quickly video conferencing is a quasi-systematic alternative to travels. And before mutualization, cancellation, and relocation. And you can find more details about this work in this paper that is already available, but which is still submitted and should be hopefully accepted very soon. In conclusion, we can point out the 2 main limits of the results. The representativity of the trajectories with only 85 mixed tables, which are composed of mostly by audience which feels concerned and is convinced in advance. And the second thing is that some important emission items are still missing, which are domain dependent. In astronomy, we have tried to include them through carbon cost of telescope observing time. A good point is that we have a strong institutional support with CNRS, IRD, other research organizations, and several universities like in Grenoble, Dijon, and Besançon. For the perspective of this work, there are several improvements to make. We need to test the method on a larger scale with the general public. We plan to produce impact path, and we must involve multidisciplinary analysis using cognitive science, humans and social science, and environmental studies. We want to adapt the tool to other cultures. This is being done for Vietnam and could be easily translated for the USA. And there are some visualization challenges, as you can see on the right part of the slide, to represent the diversity of the trajectory path. And you see that with the initial footprint where it can go with the reductions. So I would like to thank you for your attention, and I will be very happy to discuss with you during the symposium.